with questions. Questions from chapter 14. Anybody got any? Christian.
33.
Yeah.
CJ's getting a little sus about absent.
He's golfing.
Oh, God, dummy. Wow.
Just so you know.
I was gonna say, does he skip like every test, I swear? Yeah.
The West Michigan Whitecaps are trying to maximize their profits. 2 weeks ago, they found if they sold tickets for $5 each, they were able to sell 4,000 tickets. Last week, when they sold their tickets for $8, they sold 3,000 tickets. How much should they sell their tickets for in order to maximize their profits? So in this case, the profit is just going to be the ticket price times number of tickets sold or whatever. Everybody cool there? Okay. We saw that when we sold the tickets for $5, they sold 5,000, which gives us like a $20,000 profit. When we sold them for $8, we only sold 3,000 tickets. But that was a $24,000 profit. So I can see already that $5 is not going to be the optimum, right? Because we have a situation that results in more profit than that. So what I'm going to do is I'm going to look at, okay, well, how much reduction in ticket sales does like one change in ticket price result in? So we went from 4,000 to 3,000 when we moved from $5 to $8, right? So this is like the change in ticket sales per change in ticket price, right? All right, so that's going to be my key. So profits, I know if I start at $5, I'm going to sell 4,000 tickets, right? And for each unit of money, or each increase of X dollars, will result in a loss of ticket sales of 1,000 over 3 times X tickets. That's what I'm going to graph and then find the maximum of. So that's the idea there, Christian. Does that feel okay?
Yeah, makes sense. Thank you.
Yeah, no problem. Oh, is follow up on this one or something new?
Something new. It's like really quick though.
Okay, go
I
ahead.
think it's like number 3. Like the denominator says like x to the 9th power.
Yeah, I think that was just supposed to be squared, but it typoed. But if you did, it would just be like the 9 through to 9.
Yeah.
Which is like no, it's not 1. I mean, it's 1 point something, but it probably rounds down to 1. But yeah, I think that's a typo. Because I think the answer key works if it's squared.
Yeah. Look at the
Yeah, I think that's all that is. Joe.
So you don't have to do it if you don't want to, but with 34,
Yeah.
Once you get like this surface area equation, you plug in like the h. It's like the r you get, is that the answer? You have to plug that back in for all.
Right, so it wants the least amount of tin, so it's going to be the y coordinate.
Yeah.
For your like when you found the minimum on the graph, the y coordinate is your answer.
Okay, and could that be a negative?
Should not be a negative number.
I don't know if like graphed it right, but like it was like it went into the yeah, you just do it.
Sure. Joe's talking like this because he came and talked to me during community time, and we worked on, like, got the start on some of these. All right. That's why it's like he and I are having a conversation that you're like, what the heck are these two talking about? Like, it's because we had a conversation prior to class about this question. All right. Say we're trying to make a tin can. So most tin cans I've seen are cylinders. I remember that the volume of a cylinder is pi r squared times height. And I know that volume has to be 60. And the surface area for a cylinder is the top and bottom, which are circles, plus the sides. So that's going to be the circumference times the height. And what I want to do is, I'm asked about the least amount of tin that we can use. So that's going to be surface area. So what I want to do is I want to get that surface area equation in terms of one variable so I can graph it and find the minimum. So what I'm going to do is I'm going to get the either R or H by itself in the volume equation and then substitute it into the surface area equation. It doesn't really matter which one you use. I'm going to do H by itself because, well, I don't have to muck around with like a square root symbol or a plus or minus or any of that nonsense. I guess you don't really have to worry about a plus or minus since we're talking about measurements, but and I noticed that, hey, I can do some like little bit of light reducing here. So I would graph then 2 pi, I'm going to use x instead of r's because that's what my calculator works in, plus, and 2 times 60 is 120, and I still have 1r left in the denominator there. And then we'll go, I don't care, like 0 to 10, that's fine, probably. So there's what my function looks like.
So we're not going to look on the second.
Well, again, x is the radius, so it has to be a positive value. So I'm only worried about what's going on in quadrants 1 and 4. And clearly, again, the y is a surface area, so like quadrant 4 is out. It's really just quadrant 1 that I have to worry about. So whatever this value is going to be my minimum. So second trace, minimum command. Move my cursor somewhere left of where that minimum is. That looks good. Press enter. Move it to the right somewhere. That looks good. Press enter. And then enter on the guess. So a radius of 2.12 will give me a surface area of about 84.84 square centimeters. And that should be my answer. Again, since it's asking the least amount of tin, so I assume that means like area of tin. Assuming that you're using a uniform thickness the whole way through your can, which I think is probably a fair assumption. The volume is going to be, the minimum surface area is going to get a minimum volume, right? If the thickness is always going to be the same. Nolan?
Just putting something in terms of something else so you can graph it.
Yeah, I just want to get it down to one variable is all I really did there. Right? The same idea back here, like profit was in terms of 2 different variables. Ticket price and then ticket sold. What I did here was get it down so I can have like ticket price was in terms of X and ticket sold was in terms of X, where X is just the change in ticket price. Was kind of the idea again, is that I get it down to one variable. Well, or it's really 2 variables because there's like a Y or whatever, but like get it down to where I can get in my calculator. next year in calculus, if you take it, we'll learn how to do this algebraically, and you won't have to use a calculator to find a minimum or maximum. We'll look at purely algebraic techniques to do this. But you need a lot of background to be able to do that. It's like, it'd be like 2 months to build up to that point. I mean, I could show you how to do it in a day. It's not difficult, but like to understand what it is you're doing and why it's doing it, that's a little harder. But anyways, any more questions from you guys? Okay, cool. I am going to talk about this last topic. This last topic is called partial fractions. Yeah.
Can you do an example of synthetic division?
Sure. What do you want to divide?
Well, just like an example of it.
All right, so like if I have x squared plus 5x plus 1 divided by x plus 1. So on the outside, I'm going to take my divisor, set it equal to 0, and solve. That's the number that goes on the outside. On the inside are going to just be the coefficients from the numerator. I start by bringing the first number down, and then I multiply the number on the outside to the number on the bottom, write it in the next open spot, and then add down. I just kind of keep repeating. Reading from right to left, the far right number is the remainder, and then that's the constant, and that's the coefficient on the x, and the next one would be x squared, x third, x fourth, etc. Is that what you needed?
Yeah.
Okay. Joe? Go ahead, Diego.
So for
That's fine.
synthetic division and long division,
Uh-huh.
like when is it better to use one or the other?
Well, long division always works.
Okay.
Synthetic division really only, for us, will be practical when the divisor is a degree 1 polynomial with leading coefficient 1. Otherwise, you're probably better off doing long division. There's some like things that you can do to make it work for those other cases, but like probably just want to do the long division. Joe?
Can you do like a quick long division problem?
I mean, I'll just do the same one doing long division. How's that sound?
Sounds good.
So I'm going to start by just saying, okay, what times x gives me x squared? Well, that's x. So if I distribute that to both parts, and then I subtract down, x squared minus x squared is 0, 5x minus x is 4x, and bring the next piece down. And I say, okay, what times x gives me 4x? Well, that's 4. I multiply that to both pieces, and then subtract down. 4x minus 4x is 0. 1 minus 4 is negative 3. That's my remainder. Got the same thing. Cool? Nolan.
What is the, do we have to worry about the remainder, like do anything with it?
Well, if it, in regards to the asymptote for a rational function, no, the remainder doesn't mean anything. But like what this, the way you'd write your answer to this then is that this is equal to x plus 4 plus negative 3 over the divisor.
Well,
Right, that's what the remainder is really saying, is that it's the leftover part that you can't divide evenly. Is that good enough?
yeah.
Okay. John Paul, you happy?
Yeah.
Okay. Diego?
Yeah.
Good. All right. Joe, happy?
Very happy.
Okay. No problem.
Ooh.
All right. One more topic here for chapter 14, and we'll stop, say, by 1 o'clock or so that we have 20 minutes to do this homework quiz or whatever. So here we're going to talk about partial fractions. So recall back from last year, say we asked you to add these two fractions. If you wanted to add these two fractions together, what would you need to do? Make a common denominator. Great. What would that common denominator be in this case? Okay, x times x minus 2, same thing that you said. So the first fraction we need to multiply by x minus 2 over x minus 2. And the second fraction we need to multiply by x over x. So we get 2x minus 4 plus x over x squared minus 2x. Or if we just combine our like terms, we have this, right? Everybody's cool? Remember doing this? What we're going to be doing today is the reverse. It's going to be, how do I take that answer and return back to the starting problem? That's the partial fraction decomposition. Everybody's okay with the idea of what we're trying to accomplish? Okay. So let's do an example here of this. Let me find a good one. That won't be right. And then we'll talk about to just kind of outline the process. And then we'll talk about the weird things that we have to worry about. And we'll do some setups with weird things happening. And we'll do some more full examples again. So the purpose here is just kind of outline the process of what we're trying to do. Okay. So here's my fraction that I want to decompose into the sum or difference of several fractions, each whose denominator is prime or a power of prime. So first thing I need to do is figure out what denominators do I need to use. So I'm going to do that by factoring the denominator of this fraction. So I can take out an x, and then x squared minus 25 factors to x minus 5x plus 5. So this would have come from 3 fractions. Everybody's okay with that? And since each of these fractions was linear, right, degree 1 polynomial, the numerator must be just a constant. So I'm going to use the letters A, B, and C to represent the variable for those constants. Everybody's okay with that? Because I know that for when I do this partial fraction decomposition, each of these partial fractions has to be something that's technically less than 1. So the degree of the numerator and the degree of the denominator, the numerator has to be at least 1 less than the denominator, right? So the denominator is all degree 1, the numerators have to be degree 0. All right. So what I'm going to do now is this is a equation, right? Of a rational equation. I'm going to clear fractions just like I did in the previous homework sets by multiplying both sides by that least common denominator. God bless you. Everybody's cool? So when I multiply to the fraction that we started with, I just get the numerator. When I multiply to that first partial fraction, the x's cancel out, and I'm left with a times x minus 5 times x plus 5. When I multiply to the second partial fraction, the x minus 5's cancel out. So I'm left with bx times x plus 5. And I multiply to the third partial fraction, the x plus 5's cancel, and I'm left with cx times x minus 5. So far, so good? Okay. What I'm going to do now is I'm going to multiply out everything that's on the left-hand side. So I have x squared times a minus 25 times a plus x squared times b plus 5x times b plus x squared times c minus 5x times c. So far, so good? All right, what I'm going to do next is I'm going to combine my like terms. So, and the way I'm going to do the combining is based on the x's. So all of the x squareds I'm going to group together. So when I do that, I have a plus b plus c times x squared. And then I'm going to group all of the x's together. So I have 5bx and negative 5bx. So that'll become 5b minus 5c times x. And then I'll have just that negative 25a as a constant term left over. Are we all okay with how I've gotten to here? So what I notice now is that, okay, if these two polynomials are equal, then the coefficient on the left-hand side for x squared has to equal the coefficient on the right-hand side for x squared. So I can say that, okay, well, I know a plus b plus c has to equal 2. I can say the same thing about the x's. So 5b minus 5c has to equal 7. And I can say the same thing about the constants, that negative 25a has to equal 9. And that's going to form a system of 3 equations. Is everybody okay with how I got to the system? Okay? What I'm going to do next is I'm going to solve this system. If you think back to your Algebra 2 class, what was the easiest way to solve a system? No, a matrix. So I'm going to put this all into a matrix and use the RREF command, because a 3-variable system can be pretty nasty, and you may run into homework, bigger than 3-variable systems. So like, no thank you to that. So let's just kind of refresh our memory on how we solve one of these systems using a calculator. So I'm going to start by pressing second, and then the x to the negative 1 button. That'll open up the matrix menu. From there, I'm going to move over to the Edit tab, and I'm going to select a matrix to enter this information in. I'm going to use matrix A. So I know that I have 1, 2, 3 equations, so my matrix is going to need 1, 2, 3 rows. I have a column for my A's, a column for my B's, a column for my C's, and a column for my answers. So my matrix should have 4 columns. So that's all good. And then what I'm going to do is I'm just going to type in the coefficients of each row as the coefficients for each equation. So the first row is going to be 1, and then 1, and then 1, and then 2. I've already done that in my calculator. The next row would be 0, 5, -5, 7. And the last row is going to be -25, 0, 0, and then 9. Just as a little reminder, when you write your system like this and you type it into your calculator, the equal sign has to be the last column. So you might have to do, when you write your system, try to write it this way so you don't have to do an extra rearranging step. If you don't put your equals column as the last column in your calculator, it's not going to work for you when we do the RREF, and that's a bummer. Okay, I'm going to exit out of here, and I'm going to retrieve that RREF command. To get that, I'm going to press second and the matrix command. This time I'm going to go to the math tab, and I'm going to scroll all the way down until I see that RREF command. Make sure you get the one with 2 R's. So I press enter, and then I'll go back into the matrix menu, and from the names tab I'll retrieve matrix A, close my parenthesis and press enter. So this is my solution. I don't love that because I hate decimals. I'm going to turn that into fractions by just pressing the math button and then the fraction command. That'll give them as decimal or as fractions. So I have here that A is equal to 9/25, B is equal to 38/25, and C is equal to 3/25. So if I go back to my system then, or my partial fraction decomposition, I have 9/25 over x plus 38/25 over x minus 5 plus 3/25 over x plus 5. Everybody's good with how I did that?
I got a different answer.
It probably just typed the numbers into the matrix wrong. I'm positive those are the correct answers. I'm going to simplify this complex fraction because fractions on top of fractions just hurts my eyes. So if I multiply the reciprocal of the denominator to the numerators, I just get 9/25x, 38/25 times x minus 5, plus 3/25 times x plus 5. And that's what I'm going to call my final answer right there. What do you guys think? It's okay, so far so good? Okay. So let's talk about, let's make an observation here first. Notice that when I factored my denominator, each of the factors was linear, degree 1, and each of them was to the first power. Everybody see that? I'm going to look at an example now where those two things are not true for all of the factors. And on this one, we're just going to set up the partial fraction decomposition. We're not actually going to solve because, well, you'll see why. So here we have a linear factor with a degree greater than 1. That's new. And here we have a non-linear factor. Everybody's see what I'm saying there? So those are the two things you have to look out for, because we have to do something just a little bit different when we set up our partial fraction decomposition. So because I have a power of 3 attached to my factor of x, I'm going to have for sure an a over x, but I could also have a b over x squared, or I could also have a c over x cubed. So I need, if one of my factors is a power of primes, I need to make sure I have all the possible powers of that prime. So if I have p to the 5th, I need to have a p to the 1st, a p to the 2nd, a p to the 3rd, a p to the 4th, and a p to the 5th. Is that okay? Okay. So that stuff came from there. My next factor is linear and just degree 1. Or I'm sorry, it has a linear factor of a power of 1. So that's just going to be d over x plus 3. That's supposed to be a d. Doesn't look very d-ish. So nothing special that had to happen there. That's just like what we did before. Still okay? And then the last one, here I have a nonlinear factor. So I'm going to just get one partial fraction from this. But the numerator of that partial fraction needs to be degree 1 or less, right? So the way we write that is I'm going to write it as EX plus F. So if E is 0, I have a degree 0 numerator. If E is non-zero, then it'll be a degree 1 numerator. So I'll just, my bases are covered here. And you can see real quick why we're not going to actually solve this past this point, because you're going to end up with a 6-variable system and like a lot of foiling, which is not going to be a lot of fun. It's just too much work. Does this feel okay with how to get to here? Okay. Let's do another just setup, and I'm gonna ask you guys to help me do the setup, okay? So we're not gonna solve the total fraction decomposition. We're just gonna kind of do that initial setup. All right, who can tell me one of the partial fractions that I need here? Numerator and denominator. Just give it a shot, man. There's no penalties for being wrong. I just asked you if you're okay with what we just did, and everybody said yes. Okay, sure.
over x plus 10.
No.
2.
2. Right? Where is that coming from? Because we have an x plus 2, right? As a factor in the denominator. Okay, what else do we need? Okay,
X squared plus 10.
okay. Close. The denominator is fine, but the numerator is not. Not 3b.
X plus C.
There you go. Since the denominator was a degree 2 polynomial, the numerator needs it to be a degree 1 polynomial. So it needs 2 terms on it. And there's one more you guys missed.
Another
Yeah, how would I write it?
X squared.
Nope.
X
Just one time together. Or
Nope.
D.
Okay, D.
X plus 2.
Close.
squared.
Yeah, x plus 2 squared. Because that prime factor of x plus 2, you have 2 copies of it. You need a fraction with it to the first, and you need a fraction with it to the second. John Paul? Certainly. Is this starting to feel a little better?
I was confused about the square.
Yeah, what to do with it, right. It seems obvious when I'm doing it, but when you have to do it yourself, it's a little bit harder. That's okay. That's why we're doing practice, right? All right. All right. Let's go and do a full-blown couple of examples here. So we'll do the whole process on this one. What's the first thing I want to do here?
What factor the
Excellent. What does that factor to?
oh, 5. X.
X minus 5, x plus 3.
Great. Okay, so how do I write the partial fraction decomposition then?
A x minus 5.
Mm-hmm.
B. X plus 3.
Great. Anything else?
No.
No is correct. Good. We feel okay? When everything is degree 1 and linear, you just get 1 apiece, right? Nothing fancy has to happen. Now we multiply both sides of this equation by that least common denominator and multiply it to all the parts. When I multiply it to the fraction, the denominator just cancels out. When I multiply to the first partial fraction, the x minus 5s cancel and we're left with x plus 3s. And when I multiply to the second partial fraction, the x plus 3s cancel, leaving me with the x minus 5. Then we'll just distribute the a's through. So for my system, I know 5 has to equal a plus b. And I know that negative 1 has to equal 3a minus 5b. Everybody cool there? All right, let's solve this system. I'm just going to use a matrix to do it. You could probably do this one by hand. It wouldn't take too long to do. There's a 2 by 3. The coefficients are 1, 1, and then 5, and then 3, negative 5, negative 1. Exit out of here. Go back and retrieve that RREF command. And do that to my matrix A. So I get A is 3 and B is 2. So my final answer then would be 3 over x minus 5 plus 2 over x plus 3. Does that feel okay? Let's do one more example and we'll probably call her good for today. What do you guys say? Yeah? Okay. All right, so here we have negative x squared plus 2x plus 4 over x cubed minus 4x squared plus 4x. First step would be to factor the denominator. Okay, we take out the greatest common factor of x. And how does x squared minus 4x plus 4 factor? Right, but I'm going to write it as x minus 2 squared. Really important that you write it that way rather than 2x minus 2's separately. All right, so let's do our partial fraction decomposition now. What's one fraction I need?
A over x.
Great. What else?
B over x minus 2.
Great. Anything else?
Cx plus. Oh, no.
Just c over x minus 2 squared. If the factor is linear, it's always just going to be a single variable, right? I have to look at the prime itself, not the power of it, just the prime itself. The x minus 2 is linear, so it's just going to take a constant. If it was x squared minus 2, then you would need a linear numerator. Is that?
Yeah.
Okay. All right. And then we multiply both sides of our equation by x times x minus 2 squared, the denominator. And I multiply to the fraction and then each of my 3 partial fractions. So I have x cubed minus 4x squared plus 4x equals a times x minus 2 squared plus bx times x minus 2 plus cx. Now I'm doing all these reducings in my head. If that's not easy for you, feel free to write out the full multiplication and do the reducing by hand until you feel confident on it. Is everybody okay that I'm just kind of skipping that? I've been skipping that step. I feel like I probably should have said something that I'm doing that. I'm just doing the reducing in my head. Ideally, you would be comfortable doing that. If you're not, don't feel like you have to do it that way. Write a little bit more out, show some extra work. I'm now going to multiply this all out. Let me write it this way. So again, I'm going to do the same thing to set up my system. Oh my gosh, Mr. Kulik, what the heck did you do? Who sees the mistake? Yeah, I didn't write down the numerator, you dumbo. I'm going to chalk that up to being full from lunch. You guys ever do that? Come back from lunch and it's just like, boy, am I stupid. Yeah. They call that breadhead, I think is the term for that. So the x squareds I got by doing a plus b. The a, or the x's, I got negative 4a minus 2b plus c. Absolutely. And that has to give us 2. And then my last one is just that 4a has to equal 4. And shoot, guys, I can do this in this system. I think we can solve this one in our head. What's a have to equal? 1. Now that a equals 1, using the first equation, what does b have to equal?
-2.
Negative 2. And now that a is 1 and b is negative 2, what's the third equation have to be?
2.
C has to be 2. Great. So that's it. So I have 1 over x plus negative 2 over x minus 2 plus 2 over x minus 2 squared. That's all she wrote. How do you guys feel? It's all right? It'll take a little bit of practice. We'll do some more next time or whatever. I'm sure you guys will ask some questions. But I'm going to stop here. Let's do the homework quiz and then we can get out of Dodge. What do you say? Cool.